All right, so we're going to be continuing in section 13.3. And if you remember in the last video, we left off with the distance formula. And we talked about how the distance formula is derived from the Pythagorean theorem. And so we're going to begin to see some problems where we use both the distance formula and the Pythagorean theorem. And in this first example, there's a typo. So point C here is 10, -5. It said 10, -4. I've marked that out because, in spirit of full disclosure, I recorded a video using the -4. The answer ended up not being what it should have been, and so I deleted that video. Anyway, so we're going to do it again, this time with 10, -5. And so the question says to show that point A, which is 7, 4, point B, which is -2, 1, and point C, which is 10, -5, are vertices of an isosceles triangle, then show that triangle ABC is a right triangle. So we know that if it's isosceles, then two of our side lengths have to be the same length. And if we can show that that is the case, then the Pythagorean theorem will allow us to show that the three side lengths do make up a right triangle, if that's the case. Okay, so if you remember, our distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And so when you use that distance formula, remember that each order pair is an x and a y. So, for example, this is an x, this is a y, this is an x, this is a y, and then same thing here. And your 1s and 2s just mean the first point or the second point. So depending on which one you're using as your first point would be your 1s, the next point's your 2s, and so on. And so the first thing we're going to do is we're going to find the distance between points A and B. Now, let me zoom this in a little bit so we have some room here. So the distance is the square root, again, there's my 2 points, of x sub 2, which is -2, minus x sub 1, which is 7, squared, plus y sub 2, which is 1, minus y sub 2, which is 4, squared. Now, we just need to take that and simplify a little bit. And so when we do, and you can punch all this in the calculator if you need to, -2 minus 7 is -9 squared. 1 minus 4 is -3 squared. And then as you simplify that, we have the square root of 81 plus 9, which ends up being the square root of 90. Now, that does simplify. So, as a little side note here, the way I simplify radicals, and hopefully you've taken college algebra and you know this, the way I simplify that is to break the number into its prime factors. So 90 is 9 times 10, and 9 is 3 times 3, and 10 is 5 times 2. And then I take those prime factors and I circle groups of 2. Well, there's 2 3s, so I would circle those. And then for every group circled, one of those numbers comes out of the radical. And so I get a 3 that comes out. And what's left is the 5 times 2 that stays in the radical. We end up with 3 square roots of 10. Okay, so there is the length or the distance from point A to point B. That's the side length of this triangle we're talking about. Now, the next thing we're going to do is we're going to find the length of BC from point B to point C. So you can see the numbers there. So again, we're going to take the square root of our x sub 2, this time is 10, minus -2 squared, plus the y sub 2, which is -5, minus 1. And then, again, we're going to simplify that. And so we have the square root. That 10 minus a negative makes that 2 positive. So 10 plus 2 is 12 squared. And the negative 5 minus 1 is negative 6 squared. And then, again, simplify. So 12 squared is 144. Negative 6 squared is 36. When you add those together, you get the square root of 180. Now, again, we want to simplify that if we can. So if you take the 180, you break it down into its prime factors. It's 18 times 10. And 18 is 9 times 2. And 10 is 2 times 5. And 9 is 3 times 3. And then 2 times 2 times 5. And then we can circle 2 3s and 2 2s. And so 2 times 3 is 6. So 6 comes out of that radical with a 5 left. So there's the length of our next side. And then we need to find the length between A and, not A and B, A and C. So erase that. So we found the distance between A and C. So let's go up here and look at our numbers. A is x sub 2 is going to be 10, because we're using point C. So it's 10 minus 7. So 10 minus 7 squared. And then our y values are negative 5 minus 4. So negative 5 minus 4 squared. And then again, we want to simplify that. And so when we do, 10 minus 7 is 3 squared. Negative 5 minus 4 is negative 9 squared. And then as you simplify that, 3 squared is 9. Negative 9 squared is 81. And we get the square root of 90, which we already simplified. You can see that at the top of the screen. It is 3 square roots of 10. Now, excuse me. This question asks us to, number one, show that these are the side lengths of an isosceles triangle. We know that it is isosceles because this 3 square roots of 10 is the length of 2 of our sides. An isosceles triangle has 2 side lengths that are the same. And so that part is done. Okay, so I'll kind of let you see here what is on the PowerPoint. So there are each of those side lengths that we found. But now we need to show that it is a right triangle. And so this is where the Pythagorean theorem comes in. So you could take the 3 squared root of 10 times 3 squared root of 10 and see if that's going to, when you square those, see if it gives you 6 square roots of 5 squared. It is easier, though, to use the square root of 90 and square root of 180. So in our Pythagorean theorem, a squared is going to be the square root of 90 squared plus b squared, which is the other square root of 90 squared. And it should be equal to the square root of 180 squared. Now, as you simplify that, the square root of 90 squared is just 90. Same thing with the next one. And the square root of 180 squared is 180. And 90 plus 90 is 180. So that is true. So based on the Pythagorean theorem, those 3 side lengths do make up a right triangle. In our next slide, it's going to show you the Pythagorean theorem part of this. So there it is. So that's what we did, right? We said 90 squared, square root of 90 squared plus square root of 90 squared equal to 180 square root of 180 squared. And again, when you punch all that in, you will see that the left side is equal to the right side. The Pythagorean theorem does work. If you have any questions about this one, it's kind of long. It's got a couple different parts here. If you have any questions about it, let me know. All right, so look at this next one. It says that we want to determine whether the points 0, 5, 1, 2, and 2, -1 are collinear. Now, think about this for a minute. If they are collinear, then the length from A to C, so let's kind of play this out for a second. If that's point A and point B is here, then point C has to be there if they're collinear. Which means that the length from A to B, we'll call that A, and the length from B to C, we'll call that B, would have to be the same as the length from A to C. We'll call that little c. And so if we can show that their distances are the same, the A plus B equals C, then we know they're all on the same line. If we happen to have A here, B here, and then C up here somewhere, well then this length of this little c that we're talking about has to be longer than, I'm sorry, has to be shorter than A plus B. Again, we have a theorem that said that previously, that said that two sides of the triangle have to be greater than the longest side when you add them together. And so we're going to see here if that is the case. So, to keep me from having to write all this out and kind of be in the way of what the PowerPoint has, I'll just kind of scroll through this and walk you through it. So, this is what we just said. If they're not collinear, then you would have vertices of a triangle, right? Like you have in this diagram. And so AB, the distance from A to B, plus the distance from B to C would be greater than AC. Again, based on that triangle inequality that we've talked about previously. But if they're equal to each other, the distance from A to B plus the distance from A to C, the distance from A to B plus the distance from B to C, if that's equal to the distance from A to B, then a triangle can't be formed, and so the points must be on a line, must be collinear. So that's what we're trying to show, okay? So if you take those values, 0, 5, 1, 2, and 2, -1, those are the order pairs we're using, and you put those in, again, using our distance formula. What would happen here, just kind of as a little additional info to this, 0 minus 1 is -1 squared, which is 1. 5 minus 2 is 3 squared, which is 9. 1 plus 9 is 10, and so that's where that 10 comes from. Okay, so it's the square root of 10 for that number. For BC, if you did the same thing, 2 minus 1 is 1 squared, which is 1. -1 minus 2 is -3 squared, which is going to be 9. And so again, 1 plus 9 is that 10. And then, if you do from A to C, again, using those ordered pairs, you're going to have -2 squared, which is 4, and 5 minus a -1, which is +1, so that's 6 squared, which is 36. 4 plus 36 is the 40. That's where this number comes from. And so the question is, are they the same or are they not? Well, when you add the square root of 10 plus the square root of 10, you get 2 square roots of 10. When you add radicals, you add just like you do if it were an x. If that were x plus x, you would say, oh, that's 2x. Well, same thing with radicals when you add. The square root of 40, if you simplify it, again, like I talked about previously, 40 is 4 times 10. And so it's 2 times 2 times 2 times 5. Well, there's a group of 2's. Take that 2 out. What's left goes in the radical. In this case, 2 times 5, which is 10. And so you see they are the same, which is what we have there. And so because of that, these two lines, or these points must be collinear. They must be on the same line. Okay? Again, if you have any questions about that one, please let me know. Again, that's what we've said. So, let's look at this. Using the distance formula to develop the equation of a circle. So, from the distance formula, and I'm not going to walk you through how the distance formula gets used and the proof part of this, because again, it's really more involved than we want to get in this class. But you could take the distance formula and you could go about finding the equation of a circle based on it. Okay? Based on the distance formula, the radius, so this length from the center of our circle out to the outer edge, that length can be found by the square root of x squared plus y squared. Okay, again, using our Pythagorean theorem, we can see that, right? And so the equation of a circle with the center at the origin and a radius of r can be found by saying it's x squared plus y squared equals r squared. Again, that is strictly the Pythagorean theorem. Okay, that's all we're using here. So, from that distance formula, we have that if this point, this center of the circle, is not at the origin, if it's some random order pair, we'll call it HK. If that order pair is the center, then based on our formula here, this, the radius must be equal to the square root of x minus h, so whatever that x coordinate is, squared, plus y minus k squared, quantity squared. And again, that's going to give us, this is our x and y, right? So this x coordinate minus h and the y coordinate minus k squared. Again, just think about if you're doing the Pythagorean theorem, that's what we're using to be able to find this order pair. Okay, and or these this formula. And so when you go through all of that, again, I'm not going to go into tons and tons of detail here. I just don't think it's necessary. I think it will be more confusing to you than anything else. You get the equation of the circle with a center at HK is this. Now, if you've had college algebra, section 2.2 in college algebra, you learn about equations of circles. And there's not really a whole lot that you do with it in that class. You talk about how to write the general form of a circle into this form. You talk about how to identify the center and the radius, and that's about all you do. And so, not a whole lot to it if you can get your equation in this form. And so, for us, we need to know that HK, not negative H and not negative K, but the H and the K, gives us the center point, and then the R, not R squared, just R, gives us the radius. And so if you can identify the center of your circle and you can identify the radius of your circle, well, then you know what the circle looks like, because you could, again, stretch out that radius and take it all the way around where all these points are the same distance from that center. Okay, so it does come from the distance formula, which comes from the Pythagorean theorem. The proof to show you all of that would take a lot of work. It would take really more time than we need to spend on that. But that is something that I think is important for you to at least understand. A lot of these formulas are derived from other formulas. And so that does finish up section 13.3. Again, that's from the book 14.3 in your math lab. We have two other sections that I'm planning for us to do. We may hold off on those and maybe push that back and maybe put that on the final or something of that sort. So just kind of, for sure, we'll go through 13.3 or 14.3 in the math lab. The last two sections we may or may not do videos for. We'll just kind of see. But this takes you through 13.3. If you have any questions about anything we've done, let me know.